We're starting off with a review of what an x and a y-intercept is, and then we're going to see how to apply that to 3 different types of equation. So today you'll be introduced to the third form of how to write an equation of a line. So an intercept, remember, is where the graph crosses the x or y axis, and you will get an ordered pair. An x-intercept, you will have an x value, and then the y value will be 0. For the y-intercept, you have an x value of 0, and then you'll have a y-coordinate. Reviewing slope-intercept form, we're going to see how to find intercepts in all 3 forms of the line. So we've seen this before, so we'll run through it quickly. So an x-intercept occurs when the graph crosses the x-axis, and when it does so, the y value is 0. So you substitute 0 for y and solve for x. Typically, to solve for x, you would subtract 5 from both sides, but because the value of our x is negative, if I add x to both sides of the equal sign, I can get x alone faster. So I get x equals 5. Write your intercept as an ordered pair because you're going to plot it as a point on the graph. We solved and got 5 for x when we started by substituting 0 for y. To solve for the y-intercept, that's when x equals 0. So we're going to substitute 0 for x and solve for y. 0 can't be negative, so we get 0 plus 5 is 5. Again, ordered pair, we started by substituting 0 for x, and we solved and got 5 for y. So we're going to plot these 2 points on the graph, 5, 0, and 0, 5, and then we'll connect them with a line. Make sure you put arrows on the ends of your line as well. Now we're going to see how to solve for intercepts from point-slope form. So if you notice, this is the real version of the point-slope form, not my modified version, but it's the same exact process. Anytime you solve for an x-intercept for any equation, you start by substituting 0 for y and solving for x. So in this one, the first thing that I want to do to solve for x is simplify that left-hand side. 0 minus 3 is negative 3. Now I have 2 options. A lot of you might be tempted to distribute that 1/2 in, but that's going to take you longer to get x alone. What I'm going to do instead is cancel the multiplication by 1/2 by multiplying by the reciprocal, or 2 over 1. So I'm going to multiply both sides of my equal sign by 2. That'll cancel the multiplying by 1/2. On the left side I get negative 6, and then I can drop the parentheses on the right side and finish by adding 2 to both sides. So I get negative 4 equals x. Writing that as an ordered pair, I solved and got negative 4 for x when I substituted 0 for y. Solving for any y-intercept in any form of a line, I would start by substituting 0 for x and solving for y. This time I'm going to simplify what's on the right-hand side because there are no variables. So in the parentheses, I'm going to do 0 minus 2. Multiplying a negative 2 by half, I get negative 1. And adding 3 to both sides, I get a y value of 2. Writing this as an ordered pair, I started by substituting 0 for x, and I solved and got 2 for y. So I'm going to plot these on my graph, negative 4, 0, and 0, 2, and then I'll connect them with a line. Because this one was not a review, point-slope form is new to us, let's see that one more time. Solving for the x-intercept. To solve for our x-intercept, we substitute 0 for y and solve for our x value. Simplifying the left-hand side, I get 1 equals 2/3 x minus 3. This time, if I cancel the 2/3 by multiplying by the reciprocal, I'm going to get a fraction on the left-hand side. So This one, there is an option. You can distribute the 2/3 first if you want to. It still will save us some time to multiply by the reciprocal, so I'm going to go ahead and work with the fraction. On the left-hand side, we have 3/2. On the right-hand side, the 3/3 and 2/2 canceled, leaving me with x minus 3. I'm going to add 3 to both sides. 3/2 is an improper fraction, so what I'm going to do before I add it to my 3 is change it to a mixed number. 2 goes into 3 one whole time with 1 left over. So 3/2 is equal to 1 1/2, and when I add that to 3, I get 4 1/2. You want your intercepts as mixed numbers, not improper fractions. Solving for my y-intercept, I'll be substituting 0 for x, and solving for y. Simplifying on the right-hand side, I will simplify what's inside the grouping symbols. 0 minus 3 gives me -3. And when I multiply that by the 2/3, the 3's will cancel, leaving me with a -1 times 2. And then I can subtract 1 from both sides to solve for y. So I end up with a y-intercept of 0, -3. Plotting my points, I had 4 1/2, 0, and 0, -3, and then I can connect those with my line.